Welcome to Artificial Intelligence Tutorial. My name is Richard Kirshner. I'm with the Simplilearn team. That's www.simplilearn.com. Get certified and get ahead. What's in it for you today? What is artificial intelligence? So we'll start with a general concept. Types of artificial intelligence, covering the four main areas. Ways of achieving artificial intelligence. And some general applications of artificial intelligence in today's world. Finally, we'll dive into a use case predicting if a person has diabetes or not. And we'll be using TensorFlow for that in the Python environment. What is artificial intelligence? In today's world, it's probably one of the most exciting advancements that we're in the middle of experiencing as humans. So, what is artificial intelligence? And here we have a robot with nice little clampy hands. Hey, what am I? You are what we call artificial intelligence. I am your creator, reminding him who programmed him and who he's supposed to take care of. Artificial intelligence is a branch of computer science dedicated to creating intelligent machines that work and react like humans. In today's place where we're at with artificial intelligence, I really want to highlight the fact that they work and react like humans, because that is where the development of artificial intelligence is, and that's what we're comparing it to, is how it looks like next to a human. Thanks! Any tasks you want me to do for you? Get me a cup of coffee? Poof, here you go. And he brings him a cup of coffee. That's my kind of robot. I love my coffee in the morning. You'll see there's kind of a side theme of coffee today's tutorial. So here we have a robot that's able to bring him a cup of coffee. It seems pretty far out there, that we have a walking robot that's doing this, but it's not as far out there as you think. We have automatic coffee pots. We have devices that can move an object from one point to the other. Anything from Amazon delivering packages or whatever you want. All these things are in today's world. We're right on the edge of all this. That's what makes this so exciting, such an exciting topic and a place of study. So let's take a real general look at types of artificial intelligence in the really big picture. When we drill into it, there's like machine learning and all kinds of different aspects, but just a generic level of artificial intelligence. So, hi there, discovered 4 different types. Come have a look. So we have our kind of Einstein-looking guy or professor at some college. So the very first part that this is reactive machines. They've been around a long time. This kind of AI are purely reactive and do not hold the ability to form memories or use past experiences to make decisions. These machines are designed to do specific jobs. Remember I talked about the programmable coffee maker that makes coffee in the morning? It doesn't remember yesterday from tomorrow. It runs its program. Even going back to our washing machines, they have automatic load balancers that have been around for decades. So reactive machines, we program to do certain tasks, and they have no memory, but they're very functional. Then we have limited memory. And this is kind of right where we're at right now. This kind of AI uses past experience and the present data to make a decision. Self-driving cars are kind of limited memory AI. We bring up self-driving cars because that's a big thing, especially in today's market. They have all these images that they brought in and videos of what's gone on before, and they use that to teach the automatic car what to do. So it's based on a limited memory. Limited memory means it's not evolving new ideas. They have to actually, when they need to make a change, they have the program built on the memory, but then they have to make those changes outside of that and then put the new setup in there. So it's continually reprogramming itself. Theory of mind. These AI machines can socialize and understand human emotions. Machines with such abilities are yet to be developed. Of course, that's under debate because there's a lot of places that are working on the theory of mind and having it be able to cognitively understand somebody based on the environment, their facial features, all kinds of things, and evolve with them. So they have some kind of reflective ability to evolve with that. And finally, self-awareness. This is the future of AI. These machines will be super intelligent, sentient, and conscious. So they'll be able to react very much like a human being, although they'll have their own flavor, I'm sure. Achieving artificial intelligence. So how in today's world right now are we going to achieve artificial intelligence? Well, the main arena right now is machine learning. Machine learning provides artificial intelligence with the ability to learn. This is achieved by using algorithms to discover patterns and generate insights from the data they are exposed to. And here we have a computer as we get more and more to the human realm of artificial intelligence. You see this guy splits in two and he's inside his hidden networks and machine learning programs. Deep learning which is a subcategory of machine learning. Deep learning provides artificial intelligence the ability to mimic a human brain's neural network. It can make sense of patterns, noise, and sources of confusion in the data. Let's try to segregate different kinds of photos using deep learning. So first we have our pile of photographs, much more organized than my boxes in my closet of photographs. The machine goes through the features of every photo to distinguish them. This is called feature extraction. Bingo, it figures out the different features in the photos. And so based on those different features, labels the photos, it says these are landscapes, these are portraits, these are others. So it separates them in there. And if you've ever been on Google Photos, a favorite of mine, I go through there and I type in dog and I get all the images of my dog. It's pretty amazing how it's able to pull those features out. So when we're achieving artificial intelligence and the deep learning, let's take a closer look and see just how deep learning works. There are a lot of models out there. This is the most basic model used. This is a neural network. There are 3 main layers in a neural network. The photos that we want to segregate go into the input layer. And so we have a picture of Mona Lisa, it looks like, and a couple of people. When it goes into the first input layer, the arrows are drawn to like individual dots. Each one of those white dots in the yellow layer or in the input layer would be a pixel in the picture, maybe, a value for that pixel. So the picture of the mountains goes in there and it fills in that whole input layer. And then the next picture of the nightscape goes in there. The hidden layers are responsible for all the mathematical computations or feature extraction on our inputs. So when you see here, we have the 2 kind of orangish red layers here, and there's all these lines in there. Those lines are the weights. Each one of those represents usually a float number or a decimal number, and then it multiplies it by the value in the input layer. And you'll see that as it adds all these up in the hidden layer, each one of those dots in the hidden layer then has a value based on the sum of the weights. And then it takes those and it puts it into another hidden layer. And you might ask, well, why do we have multiple hidden layers? Well, the hidden layers function as different alternatives to some degree. So the more hidden layers you have, the more complex the data that goes in and what they can produce coming out. The accuracy of the predicted output generally depends on the number of hidden layers we have. So there we go. The accuracy is based on how many hidden layers we have. And again, it has to do with how complex the data is going in. The output layer gives us the segregated photos. So once it adds up all these weights, and you'll see there's weights also going into the output layer, based on those weights, it'll say, yes, it's a portrait, no, it's a portrait. Yes, it's a landscape, no, it's a landscape. And that's how we get our setup in there. So now we were able to label our photos. Let's take a look and see what that looks like in another domain. We have photograph domain. Now let's look at it in the airline ticket. So let's predict the airline ticket prices using machine learning. These are the factors based on which we're going to make the predictions. And choosing your factors is so important. But for right here, we'll just go ahead and take a look at what we got. We have airlines, we have the origin airport, the destination airport, the departure date. Here are some historical data of ticket prices to train the machine. So we pull in the old data. This is what's happened over the years. Now that our machine is trained, let's give it new data for which it will predict the prices. And if you remember from our 4 different kinds of machines, we have machines with memory. Well, this is the memory part. It remembers all the old data and then it compares what you put in to produce the new data, to predict the new prices. The price is $1,000. That's an expensive flight. Of course, if that is US dollars, if it's India, I don't know what the price range is on that. Hopefully it's a good deal for wherever you're going. So we predict the prices, and this is kind of nice because if you're looking way ahead, it'd be nice to know if you're planning a trip for next year, how much those tickets are going to cost, and they certainly fluctuate a lot. So let's take a look at the applications of artificial intelligence. We're going to dive just a little deeper because we talked about photos, we've talked about airline ticket prices, kind of very specific, you get one specific number. But let's look at some more things that are probably more in-home, more common right now. Speaking of in-home, this young gentleman is entering his room. Of course, makes a comment like we all do when we walk into a room. This room is dark, isn't it? Let's see what happens when I enter it. The sensors in my room detect my presence and switch on the lights. This is an example of non-memory machines. Okay, it senses you. It doesn't have a memory whether you've gone in or not. Some of the new models start running a prediction as to whether you're in the room or not, when you show up, when you don't. So they turn things on before you come down the stairs in the morning, especially if you're trying to save energy. You might have one of those fancy thermostats, which starts guessing when you get up in the morning, so it doesn't start the heater until it knows you're going to get up. So here he comes in here, and this is one of the examples of Smart Machine, and that is one of the many applications of artificial intelligence, one of the things we're developing here in our homes. Okay, bye. Abruptly he leaves, leaving his nice steaming cup of coffee there on the table. And when he leaves, the sensors detect he's gone and turn off the lights. Let's watch some TV. Did someone say TV? The sound sensors on the TV detect my voice and turn on the TV. Sounds kind of strange, but with the Google dongle and a Google Home Mini, you can actually do just that. You can ask it to play a movie downstairs on your downstairs TV. True also with the Amazon Fire Stick and all the different artificial intelligent home appliances that are coming out. Pretty amazing time to be alive and in this industry. Here you have one more application of artificial intelligence, and you can probably think of dozens of others that are right now on the cutting edge of development. So let's jump into my favorite part, which is a use case. Predict if a person has diabetes. And in the medical domain, I mean, if you read any of these, they say predict if a person has diabetes. But in the medical domain, we would want to restate this as, what is the risk? Is a person a high risk of diabetes? It should just be something on their radar to be looking out for. And we'll be helping you out with the use case. There we are with a cup of coffee again. I forgot to shave, as you can see. We'll start with the problem statement. The problem statement is to predict if a person has diabetes or not. And we might start with this prediction statement, but if you were actually using this in a real case, again, you would say you're high risk of diabetes would be the proper way to present that to somebody if you ran their test data through here. But that's very domain specific, which is outside of the problem statement as far as a computer programmer is involved. So we're going to have a look at the features. These are the things that have been recorded, and they already have this data from the hospitals. One of them would be number of times pregnant. Obviously, if you're a guy, that'd be 0. Glucose concentration. So these are people who've had their glucose measured. Blood pressure. Age. Age is a big factor, an easy thing to look at. Insulin level. So if someone's on insulin, they probably have diabetes. Otherwise, they wouldn't be taking insulin. But that would affect everything else, and we add that in there if they're using insulin. Let's start off with the code. So we're going to start off by importing parts of our data set. And if we're going to do this, let's jump into one of our favorite tools. We're going to use the Anaconda Jupyter Notebook. So let me flip over to there, and we'll talk just briefly about that, and then we'll look over this code. So here we are in the Jupyter Notebook, and this is an inline editor, which is just really cool for messing with Python on the fly. You can do demos in it. It's very visual. You can add pieces of code. It has cells, so you can run each cell individually. You can delete them. You can tell the cell to be a comment, so that instead of running it, it just skips over it. There's all kinds of cool things you can do with Jupyter Notebook. We're not going to go into that. We're actually going to go with the TensorFlow. And you do have to import all the different modules in your Python. Now, if you're in a different Python IDE, that's fine. It'll work in just about any of your Python IDEs. And I'll point out the one difference in code when we get to that, which is the inline for doing our graph. And in this code, we're going to go through, we're going to load our data up, we're going to explore it, we're going to label it, and then we'll use the TensorFlow, and then we'll get down to the end where we're going to take a look at how good the model is. Does it work? So let's start with the top part here. And let me go ahead and let's paste that code in there. I've added a line in at the top. I've added the folder, because I didn't put it in the same folder as the program that's running. You don't need to worry too much about that, but if you have a folder issue or it says file doesn't exist, you probably have it in the wrong folder, or you need to add the folder path. And then we're going to import pandas. And let me just, one of the cool things, since it's in Chrome, we can just do that Control plus and zoom right in there. And we have the import pandas as PD. So go ahead and draw a line in there. You can see that the pandas as PD, add a little drawing thing in there to make it a little easier to see. Pandas is a data set. It's a really nice package you can add into your Python. Usually it's done as pandas as PD. That's very common to see the PD here. Let's circle that. It's basically like an Excel spreadsheet. It adds columns, it adds headers, it adds a lot of functionality to look at your data. And the first thing we're going to do with that is we're going to come down here and we're going to read. And this is a CSV. It's a CSV file. You can open up the file on your computer if you want. If you need access to the file, you can either search it and download it from the main thing, or type a note in down below on the YouTube video, and Simplilearn will help you get that file also. And that's true of any questions you have on this. You can add comments down there, and somebody at Simplilearn actually keeps an eye on that, and we'll try to answer those questions for you. I put in the full path. You don't have to if you have your data file saved in the same folder you're running your program in. And this is just a CSV file, comma-separated variables. And with the pandas, we can read it in there, and we're going to put it right in a variable called diabetes. And then finally, we take diabetes, and you'll see diabetes.head. This is a pandas command, and it's really nice because it just displays the data for us. Let me go ahead and erase that. And so we go up to the Run button up here in our Jupyter notebook, which runs the script in this. That's the cell we're in. And as you can see with the diabetes.head, since it's a pandas data frame, it prints everything out nice and neat for us. And this is really great. And if I go ahead and do a control minus, I can get it all to fit on the same screen. And this is the first 5 lines. When you do the head of the data, it just prints out the first 5 lines. In programming, of course, we start with 0. So we have 0, 1, 2, 3, and 4. Here we go. Here we go. We start with 0. We have 0, 1, 2, 3, and 4. We have our titles going across the top. And of course, the first column is number of pregnancies, glucose concentration for the second one, blood pressure, measurements of triceps. As we keep going, you'll see, you can guess what most of these things are. Group, I'm not sure, this is probably the test group. I didn't look it up to see specifically what that is. Anytime you start exploring data, and for this example, we don't really need to get too much in detail, you want to know the domain. What does this information mean? Are we duplicating information going in? That's beyond the scope of this. For right now, though, we're just going to look at this data, and we're going to take apart the different pieces of this data. So let's jump in there and take a look at what the next set of code is. So in our next setup, or our next step, we got to start looking at cleaning the data. We got to start looking at these different columns and how are we going to bring them in? Which columns are what? And I'm going to jump ahead a little bit, and also as we look at the columns, we're going to do our import our TensorFlow as TF. That's a common import, but that's our TensorFlow model. TensorFlow was developed by Google, and then they put it into open source so that it's free for everybody to use, which is always a nice thing. So let's take a look at what these 2 steps look like in our Jupyter notebook. So let's paste this code in here, and this is something that happens when you're messing with data, is you'll repeat yourself numerous times. We already have diabetes head, so I'm going to put the little pound sign, which tells Python that this is just going to be a comment. We're not going to run it a second time. In here we have diabetes.columns, and then diabetes columns to norm equals diabetes columns to norm.apply lambda x. Let's talk about that, but let me first run that, and let's see what that comes out with that. And then let's put the next set of code in also. And I'm going to run that. Let me just hit the run button. It doesn't really have an output, but we did a lot of stuff here. So let's go over what we did on this. So I've turned on my drawing implement to help go through all this, because there's a lot going on here. The first thing is we have all of our columns up here, all of our column names. Let me just highlight that and draw a circle around that like we did earlier. And we want to look at just specific columns. And we're going to start, let me change the color on this so it really sticks out. We'll use like a blue. I'm going to look at these columns. And we're not going to do age, class, or group. We're going to look at those in a different way. And I'll explain in a little bit what that's about. So we're looking at number of pregnancies, basically anything that can be read as a float number. And you might say age could be read as a float number. We're going to address that differently because when you're doing statistics, we usually take the ages and we group them into buckets. And we'll talk about that. And so we're going to take these columns and we're going to do what they call normalize them. Column to normalize. What is normalize? If you're using the sklearn module, one of their neural networks, they call it scaling or scalar. This is in all of these neural networks. What happens is if I have 2 pieces of data, and let's say one of them is, in this case, 0 to 6, and one of them is in insulin level is 0 to maybe 0.2 would be a very high level. I don't know what they actually go to. A neural network will look at this 6, and it'll go 0 to 6, and as you get into 0, 6, here's an 8, even a higher number, it will weight those heavier. And so it'll skew the results based more on the number of pregnancies than based on the insulin or based on the blood pressure. So we want to level the playing field. We want these values to all be in the same area. We do that by normalizing it here. And we use a lambda function. This is always a kind of a fun thing. We take the diabetes, It's a panda setup, and let me just erase all that so we can go down here, put it back to red. And we take our diabetes, which is a panda data set, and we only want to look at the columns to normalize, because that's what we built. We built a list of those columns, and we're going to apply a lambda function, and you'll see lambda in all kinds of Python programming. It just means it's a function. We put x in, and whatever is outside of the x over here, it then takes that and returns that value. So the new value is going to be whatever x is minus x min. Again, it's a pandas data set, so we can get by with that, which is really cool. It makes it easy to read. So we take x, we look for the minimum value of x, and then we divide that by the maximum value of x minus the x min, or the width. And what this essentially does is if you're going from 0 to 15, it's going to divide by 15, and then we subtract it. Let's make this 2 instead of 0. Or 20 to 115. There we go. First off, we set this to 0, so we subtract x min. So right off the bat, the minimal value is going to be 0. And then we divide it by the difference here, x min minus x max, or x max minus x min. This basically sets all the values between 0 to 1. And that's very important if we want to make sure that it's not going to be a skew in the results, if it's not going to weight the values one direction or the other. 0 to 1. That's what this is doing. And again, there's like so many different ways to scale our data. This is the most basic scale, it's standard scaling, and it's the most common. And we spelled it out in the lambda. There's actual modules that do that, but lambda is it's such an easy thing to do, and you can really see what we're doing here. So now we've taken these columns, we've scaled them all, and changed them to a 0 to 1 value. We now need to let the program know, the TensorFlow model that we're going to create, we need to let it know what these things are. So to do that, I create a variable called number pregnancy, keep it simple, and we've imported the TensorFlow as TF. One line of code brings our TensorFlow in for us. Awesome. Love Python. So you get number of pregnancies and tf.featureColumn.numeric column. We're going to tell it's a numeric column, so it knows that this is a float value, 0 to 1, and then number underscore pregnant. So we're taking that column and we've reshaped that column from 0 to 1. And no, that doesn't mean you have a 0.1 pregnancy. It just means 0.1 equals 1 or something. Number pregnant. So we're just mapping this data. So TensorFlow knows what to do with it. And we go through all of these. We go through all the way up to, again, we're not doing age. Let me just separate age down here. These have all been adjusted. Age, we're going to handle differently. We still put it as a numerical column because it is. So let me just circle age. And group, we didn't even touch group yet. We're going to look at group and age, and we're going to do some special stuff with that. Class, we're going to look at last. Why? Because this is whether they have diabetes or not. That's what we're testing for. So this is our history. We know these people have diabetes or not, and we want to find out, we want to create a model, and then we want to test that model predicting whether somebody new has diabetes or not. So here I am still with my cup of coffee working away, refill number 3. Let's explore both the categorical group, which is going to be the A, B, C, and D on the end, and also the age. We're going to talk about those a little bit more. And then we're going to combine all those features, and we'll jump into splitting the data, although that's kind of the next step. But we'll put that all together. What are we doing with the age, and what are we doing with the group down there? So let's flip on over and take a look at our Jupyter Notebook. So the first thing is let's put this new set of code in here and run it. And let's talk about what we're doing on this set of code. And I actually want to go one more step forward on the next set of code, or part of it. There we go. And I can go ahead and just run that while we have it. That's fine. Let's just scroll up a little bit here, and let's go through what we just did with this set of code. If we go back up here to the top part, we have group B, C, B, B, C, we learned from the header. So when I come down here, we're going to create assigned group. And let me get my drawing pad out. So we're looking at this first one up here, assigned group, TF feature column, categorical column with vocabulary list. Whew, that is a mouthful. This is saying that this is a categorical list. In this case, we have A, B, C, D. You see this a lot in TensorFlow. A lot of times TensorFlow is used to analyze text or logs, error logs, and they're just full of all this information, and they take these, in this case A, B, C, D, but in other cases it'd be words, and they create numbers out of them. So it has 0, this is one column, this is another column, this is another column, this is another column. And it's just this way of being able to look at this in a different light and assigning them different values. You really don't want to assign this a float value. first thought might be, let's assign this 0 to 3, 0, 1, 2, 3 for A, B, C, D. But if you did that, it would try to add 1 plus 2 to get 3 as part of its math and functions. And that just isn't true. C does not equal A plus B. C is just a categorical name. It could have been the Frank group and Laura's group and Abid's group, but it's not. They're not float numbers. So very important that you have that distinction in your data. The next step we're looking at is our matplot. And we're going to do this. This is a cool, useful tool. We're going to import matplotlibary.pyplot as PLT, a standard import. And this next line here is really important. For doing the matplot library, we want it to be inline. That's because we're in a Jupyter notebook. Remember I told you before that if you're running this in a different IDE, you might get a different result. This is the line you need if you want to see the graph on this page. And then we do diabetes, and we're going to look at just the age, and .hist bins equals 20. What the heck is that? Well, it turns out that because this is, remember it's a pandas, there's our PD, pandas as PD. Because this is a pandas, panda automatically knows to look for the matplot library. And a hist just means it's going to be a histogram. And we're going to separate it into 20 bins. And that's what this graph is here. So when I take the diabetes and I do a histogram of it, it produces this really nice graph. We can see that at 22, most of the participants in this, probably around 174 of the people that were recorded, were of this age bracket. They're right here in this first column here. And as they get further and further down, they have less and less and less until when you're at 80, you can actually see down here there's almost none in a couple of these categories. And this is important to note because when you're doing census, the older the group is, the more the people have passed away. So you're going to have this in any of your censuses you take. You're always going to have a much larger group in the younger crowd, and then it gets lower and lower as they get older. And I mentioned the word buckets. Here we go. We're going to create an age bucket. We're going to put people in buckets. Can you imagine people sitting in buckets? Kind of a funny way of looking at it. This just makes it easier for us to separate it. When I go to the doctor's office, I don't want to be told, well, you're age 22. This is your, you'll get a decent one at 22. Here we are back to my cup of coffee. I told you coffee was an underlying theme. These next couple steps are very specific to TensorFlow. Up until now, we had some TensorFlow as we set the categories up, but you'd have to set that up with any model you use to make sure they're set correctly. They'd be set up a little differently. But we run input functions. And in TensorFlow, this allows for some really cool things to happen. And this is why TensorFlow is so predominant in a lot of areas. So let's take a look at these next couple lines of code here. We're going to create the input function, and we're going to go ahead and create the model. And let me go ahead and put these codes in here. I went ahead and split it up so it has different lines, so we can talk a little bit about that. And then the actual model. And let me go ahead and run this so we can see what that looks like. And in my particular environment, it just prints out a little bit of information about the model. Not too worried about looking at that, but we do want to take a closer look at what we did here. So we've created an input function. And again, this is very specific to TensorFlow. With the input function, we have our train. We have our x equals x train and our y equals y train, because we want to train it with a particular information. But we have these other settings in here, these two settings. And the number of epochs is how many times it's going to go over our training model. Epoch means large, so it means all the data. So we're going to go over it 1,000 times. That's actually a huge overkill for this amount of data. Usually it only needs probably about 200, but when we're putting it together and you're trying things out, you just kind of throw the numbers in there and then you go back and fine tune it sometimes. The batch size is really important. This is where TensorFlow does some really cool things. If you're processing this over a huge amount of data and you try to batch everything at once, you end up with a problem. This means we're only going to read 10 lines at a time through our data. So each one of those rows of testing they've done, we're only going to look at 10 of them at a time and put that through our model and train it. And then shuffle is self-explanatory. We're just randomly selecting which data and what order we go in. That way, if there's 5 in a row that are kind of weighted one way and vice versa, it mixes them up. And then finally we create our model. So the model goes in there and goes, okay, I have a tf.estimator.linear classifier. We're going to put in the feature columns equals feature columns. We defined all our columns up above. And then we have in classes equal 2. And that just means we have our out result is 0 or 1. You have diabetes or you don't have diabetes, or in this case, we actually call it high risk of diabetes. And then I put one more line of code in there, which I forgot. We've set up our model. We set up our feature columns. Now we need to actually train it. Model.train. You'll see this so common in so many different neural network models. This is like a standard. What's different though is we have to feed it the function. Remember we created this function with all this information on it. And then we have steps. And steps similar to number of batches and batch size. It's more like individual lines we step through. 1,000 is a lot more common for steps than epochs. But steps is used. You could probably leave this out in this particular example. And let's go ahead and run this all together, because it has a slight, when we start training it, we get a different output. So here we go. I've run it. It's given me the information from when I created the model. And now it just starts going through and we get this information. Tensor loss equals global step. All kinds of stuff going on here. And if you're following this, it's just going through the steps and training it. It gives you information. You could dig deep into here, but for this particular setup, we're not going to go too deep on what's going on. Just know that we've trained our model. This model now has the information we need in it to start running predictions. So as we sip our next, take our next sip of coffee, or maybe it's tea, or if you're one of those strange late night workers, maybe it's a sip of wine. We go into the next step and we actually want to run some predictions on here, but we don't want to run the training. We want to run the test on there. We want to take our test data and see what it did. And so that's what we're going to do next, is we're going to run the test through and actually get some answers. So if you were actually deploying it, you would pull the answers out of the data it's bringing back. Let's take a look at that in our Jupyter Notebook. So here we go. Let's paste it in there. I'm going to go ahead and run it. And you'll see that as it goes, it's actually putting the answers out. If you remember correctly, well, we'll walk through this here in just a second, but it goes through and it runs each line and it gives you a prediction for each line one at a time and prints them out. So let's take a look and see what that actually looks like. Let's start with this first part. We've created another function. This is just like the other function, except for x equals x test. And there's no y. Why is there no y? Because we don't know what the answer is on this yet. We don't want to tell it the answer. We want it to guess what the answer is. So we can evaluate that and see how good it did on that 33% of the data. So this is our X test. Batch size is 10 again. So if we were watching this roll down here, we would see that it actually processes it 10 lines at a time. It's only going to go through once. It goes through all the X test data one time. We don't need to have it predict multiple times. And shuffle equals false. Very important we set the shuffle to false, because if we were tracking this and actually giving people answers, we'd want to make sure it connects to the right person so they get the right results. But of course, we're just doing this to evaluate it. So let's take a look down here what it put out. And as I scroll down in my Jupyter Notebook, we have some information as far as the TensorFlow running and then the actual output. And if we look at the output, we know by this first bracket in Python it's an array. We know by this squiggly bracket that this is a dictionary, so that this is a label. The dictionary has logistic, probabilities, class IDs, classes, and so this whole first part, let me redo that. This whole first part is one output. And we know that because there is the bracket there, and there is this bracket here for the dictionary. And it's a dictionary of terms. So if I pulled this out and I looked at object 0 in here, I would go down to, and let me just find it, here it is, classes. Remember how we defined classes? We define classes as our answer. And so it's guessing, our TensorFlow says, based on all the information you gave me, I'm guessing this first entry of our first test data is high risk diabetes. Uh-oh, go get tested. Change your diet. Watch what you're eating. You know, high risk, 1. And if we go down far enough, we can see down here is another one where classes equals 0. I skipped a couple because they're all 1s up here. The B, this particular output, B, in front of the 1 means it's a binary output. It only comes out as 0 or 1. And there's a lot of other information in here. You can dig deep into TensorFlow and explain these different numbers. That's way beyond the scope of what we're working on today. So the basics of it, though, is you get an output. And we have an output of whether the person has diabetes or not. Well, in this case, it's high risk of diabetes or not. So now that we've run our predictions, take a sip of coffee, a short break, and we say, well, what do we need to do? Well, we need to know how good was our predictions. We need to evaluate our model. So if you're going to publish this to a company or something like that, they want to know how good you did. Let's take a look at what that looks like in the code. So let's paste that in here, and just real quick, go back over this. By now, this function should look very, we're going to call it eval input function. It should be pretty straightforward here. We have our TF estimator inputs, pandas input function, And then we have our X test, our Y test. This time we want to give it the answer so it has something to see how good it did on. Batches 10, processing 10 at a time. We're only going to go once through the data. We're not shuffling it, although it doesn't really matter with this. And then we're going to do results equals model.evaluate. And we put our evaluation function in there. This should all look familiar because we're repeating the same thing. It's very similar with a couple different changes as far as what we're feeding it and the fact that we're doing an evaluation. Let's see what that looks like when we run it. And we go up here to our run model. You'll see warnings on some of these because I didn't install this on its own install. So a lot of it is temporary files because I'm using the Jupyter Notebook instead of setting it up on a regular machine. And we get our output. And we'll go ahead and just look at this output real quick and then we'll flip over. And from here you'll see that it generates an accuracy, a baseline, average loss, the mean, gives you precision, prediction. It gives you all kinds of information on here. So let's flip over and see what's important. And we'll look at the slide. Here we are in this slide. And this should be exciting because we just about wrapped up our whole TensorFlow. And TensorFlow is one of the more complicated models out there. So give yourself a pat on the back for getting all the way through this. When we look at this output, we have an accuracy of 0.7165. That's really what we want to look at. That means that we have an accuracy, if you're just truncating it, of 71%. That's quite good for our model. You know, given a small amount of data, we came up with a 71% of letting people know they're high risk or not with diabetes. So we created a model that can predict if a person has diabetes based on some previous records of people who were diagnosed with diabetes. And we managed to have an accuracy of 71%, which is quite good. The model was implemented on Python using TensorFlow. Again, pat yourself on the back because TensorFlow is one of the more complicated scripts out there, but it's also one of the more diverse and useful ones. So the key takeaways today is we've covered what is artificial intelligence with our robot that brings us coffee, and we noted that we are comparing it to how it reacts and looks like humans. Very important to note that in today's world and where we're at. And we looked at types of artificial intelligence from the reactive machines to limited memory and looking into the future of theory of mind and self-awareness. And then we went in there and took a look at taking photos and how artificial machine learning work. We took a glance at deep learning with our neural networks and how we have hidden layers in our input layer and our output layer. We then looked at a use case of somebody walking into a room and activating their TV using artificial intelligence, or part of the AI category. And finally, we dug in deep and we did some coding in the TensorFlow in Python. With that, let's wrap it up. I'd like to thank you for joining us today. For more information, visit www.simplilearn.com. Get certified, get ahead. Again, if you have any questions or would like some verifications or more information, please feel free to add a note in the YouTube video comment section. We look forward to hearing from you, and I wish you a wonderful day.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.